Okay, so hi, welcome to an introduction to AI, artificial intelligence, and to Gaia. So we'll quickly introduce ourselves. So hi, my name is Leah. I'm an 11th grader at Horace Greeley High School, and I am doing some science research outside of school in machine learning and AI, and I recently took an AP computer science class at my school.
Hi, my name is Chloe. I am also an 11th grader from Pleasantville High School, and I have taken APCS as well, and I am the head lab assistant for my school's computer science program. So just an introduction to, in general, what artificial intelligence is. So artificial intelligence is essentially an umbrella term that's used to describe machines that have the ability to think on their own, to think logically. Essentially what you're doing is you're creating your own brain using code. So under the umbrella term of artificial intelligence, there lies subcategories or smaller categories such as machine learning and deep learning. So machine learning uses programming to be able to make decisions and predictions regarding different problems or different categories. And then deep learning is another subcategory of under artificial intelligence, and then machine learning, there's deep learning. So in deep learning, it finds the best method to approach different problems, to find solutions, and we do all of that through code. And so some applications of artificial intelligence that you might be familiar with. So if anyone has an Amazon Alexa or an Apple Siri, then they have been in touch with artificial intelligence. Those are voice assistants that use this code to be able to give you updates on the news, to give you weather updates, to personalize different data for you, and then autonomous vehicles. So vehicles such as Tesla's self-driving technology that uses artificial intelligence to be able to navigate its surroundings, to make decisions to lane change or to stop. And then if anyone is familiar with TikTok, so essentially artificial intelligence is used to curate your For You page. So if you like a video or you watch a certain video for a longer proportion of the time, then they'll give you more videos that are more like that. And then some other examples are if anybody uses Face ID for their iPhones or for their iPads, that uses artificial intelligence to be able to identify your face from different angles or when you're wearing something over your face, like sunglasses or now masks, and then spam filters for email boxes. So a lot of emails that send to you through mass to send to mass recipients or that have a bunch of keywords, those are used and dedicated to a certain folder so you don't have to look at them with your primary emails or emails that are from people and locations that you're more familiar with and that you open more frequently. So essentially we started Gaia because we wanted to increase the female representation in the computer science field. As of right now, there are only, out of all the people who are computer science, only 20% of those are female. In artificial intelligence in specific, 26% of those are female. And I think that computer science can be a really daunting and really scary field for those who are just starting, but we're hoping to show you how fun and interesting artificial intelligence and computer science as a whole can be. And through exposing you to different problems or different ways to code or different applications to coding, then we think that you guys will develop a real hobby in it or even one day want to pursue a career in the field.
So I'm going to sort of run through the basic steps of how to train a machine learning model. And so the first thing you're going to want to do is like data processing. So when you're training a machine learning model, it uses oftentimes a lot of data. And oftentimes these are very large amounts of data. And the first thing you want to do is make sure that your data is all in the right format. You want to make sure that your numbers are all in the same units. You want to make sure that's the unit that you want. Maybe you want to break up some of your data or change some of your data and make sure just that all your data is ready to for the machine learning model to train on it. And so this is actually a lot of what you often do when you're training a machine learning model. And so this is kind of has to be done before you can even start to train your machine learning model. So in terms of this data, so a data frame is a really good way to work with your data and to visualize your data. And so kind of what I showed on the slide is a data frame. Essentially, it has a number of columns and a number of rows. and each row would represent one sort of sample of your data, and each column would be sort of like a feature or a characteristic of that data. So in this example, we have like the name and the grade or the mark, and that would be each sort of a characteristic of each of these samples that we have for our data. And so you might want to manipulate this data a little bit working with your data frame. And then once your data is all ready, you can train a machine learning model. And so during model training, a machine learning model is given a set of features and it attempts to predict a label. And I'm going to explain that a little bit. So a good analogy would be if you have like an infant and it's trying to learn to tell whether a given fruit is an apple or a banana. And so the way that the infant would start to differentiate between these two different fruits is by looking at certain characteristics of the fruit. For example, the color of the fruit, the shape, the taste. And they would start to learn that, for example, an apple would generally have a red color, while a banana is more yellow. And maybe an apple has like a spherical or a round shape, and the banana has more of like a longer curved shape. And as they kind of looked at these fruits, they would start to learn how to tell differences between the two fruits. And so a machine learning model is going to do something pretty similar. And if we take this example of trying to determine the type of fruit, and we go back to the data frames, you might have a data frame that looks a bit like this. So the features for this data frame are going to be the different characteristics of the fruit, the color, the shape, the taste. And the label is what you're trying to determine. And in this case, you're trying to determine the type of fruit. So in this case, the label would be either an apple or a banana. And so the way that the machine learning model would then go about this is it would go through many tries and it would try to learn patterns in these features that can then be used to predict the label. So for example, the machine learning model might look at this data and it might say, maybe all the fruit that are red are bananas. And if it assumed this pattern, it would be pretty inaccurate because all the fruit that are red are actually apples. So when it tried to use this pattern to predict the labels, it would be wrong. So then the machine learning model would try again, and this time it would learn a different pattern. And sorry, we're just getting one other person coming into the meeting now, I think. If the machine learning model would try again with a different pattern, and this time maybe it would think to itself, what if all the fruit with a tart taste are apples? And this time, if it picked up on this pattern, it would be more accurate. So then it would go with this pattern for the future, and it would say that this pattern was more helpful to it. And so essentially it's just going to go through a number of tries, and each time it's going to pick up on like a different pattern in the data, and eventually it's going to get to one that's really helpful and helps it determine the type of fruit. And so this might sound pretty difficult to code, but the good thing is that there's actually a lot of these machine learning models have already been coded, and they're already out there and available to be used in what are called libraries. And so libraries essentially just contain large amounts of really helpful code that have already been written. And you can just import these libraries and you can use the code, but you don't have to write it yourself. And so one of the libraries that you might use a lot in machine learning is called scikit-learn. And this library contains just tons of code for a lot of different types of machine learning models and a lot of other helpful things that you're going to want to do with these machine learning models. And so once you import these libraries, you can use all of the code in them for yourself. And so, for example, once you have the library, once you have your data, training a machine learning model can just be like one line. Like this line here, it essentially calls this thing called fit, or basically it just trains it. And what it's telling the computer to do is to use this method and this code that's been coded by someone else that's already in the library, and just to use it for your own data. And all this line would essentially be training your model. And it can be really simple. It can just be one line once you use these libraries. And so once you train your machine learning model, you might want to sort of like evaluate how well your model did. And so to do that, you would tell the model with the patterns that it learned on the data, and you would have it try to predict a new piece of data. And you would see how well it did, like how close its prediction and its guess was to what the actual value or the actual label that you know. And you would just maybe do this with like a large number of tries, and you would just see how well the model was able to apply the patterns that it learned to this new data. And so there's going to be a lot of like complicated math and code going on behind the scenes, But like, unless you really want to focus on coding your own models, and unless that's kind of what you want to do, you don't really need to know or understand all the code. You just want to be able to apply it. And so it can seem very scary, but really applying it, you don't have to understand like every little bit of the code. And you just have to be able to apply it. So now we're gonna kind of see how it works. So we're gonna use a site called Google Colab. And I already wrote some code for you guys. So we're just gonna try to run it together. And so we're gonna, sorry, someone else just came into the Zoom. So we're just gonna run this code together, and you don't have to understand all the code. We're gonna go into that more in later meetings if you're interested. So what I'm gonna have all you do is I'm going to share this. It's called Google Colab, and it's just a way to easily run Python code. So I'm going to share it with you, and I already have the link. So I'm just gonna drop the link into, I'm going to drop the link into the chat. And if you guys want to open that up, and then I'll kind of go through all the steps one by one. Oh, let me try, sorry, just disconnected. Yeah, so if you wanna, we'll go through the steps one by one. And if you have any questions, any problems, just shoot me a chat or Chloe a chat. And so let's just all kind of try opening this up and just click on the link in the chat. And so once you have it open, I'm not sure if you guys have all done that. Once you have it open, you're just going to go to this file button at the top and go down to see where it says save a copy in Drive. And you're just going to want to click on that so you can make a copy of the code yourself. And once you do that, it'll tell you it's creating a copy, and it'll open in a new tab, your own copy of the code, so that you can run it and we can all run it together, but on our own code. So I'll give you guys a little bit of time to do that. So if everybody is ready, if you're not, just shoot me a chat, but I'm just going to start kind of going through some of this stuff slowly, and we're just going to take it one step at a time. And I'm going to be going through some code. We're going to go into more depth and more detail on how the code works. For now, you don't really have to understand it. I'm just going to tell you what it does, and we'll kind of explain it a little more and some other syntax in our next meeting. So the first thing that we're going to do is we want to import our libraries. And so like I mentioned before, the libraries are going to contain a lot of really helpful code so that you can just run the code yourself and you don't have to actually code it. And so the two libraries that we're going to be using in this example, one of them is called Pandas. And this has a lot of code for working with data frames, for visualizing your data. And this is really helpful because, like I mentioned, a lot of times you're going to want to do data processing and working with your data before you can even train your machine learning model. So you're going to be using a lot of this stuff in Pandas to do that. And so the second line, so that's what the first line does. And the second line is going to import a type of model. So in this case, we're going to be using a linear regression model, and that's just the name of the model. You don't really have to understand exactly how it works. It's a little complicated. There's some math, but essentially it's already been coded for us. So we just want to import a library with that second line, import that model. And we're importing that from the library scikit-learn or sklearn. And so if you guys want to try running it, if you hover over this box with this code, there's going to be a little button where there's like the play arrow. So if you just click that, and then once you get this little check mark, that means that you just ran that code. So if you guys want to all try doing that, that way we can kind of do it ourselves, or if you just want to watch, that is totally fine too. So the next thing that we're going to do is create a data frame. A lot of times when you are actually training a machine learning model, you're going to have like these huge amounts of data, and you're probably just going to read them from a file. But for now, so that you don't have to like download anything, and so it's easier, I just created a quick sample data frame. So all that this code essentially does is make that data frame for you. So if you click the little run button again, it'll run, and you can do that as well. And so I called this data frame sample underscore data underscore frame, because you have to give names, they have to be one word in Python. And so if we run this next little cell where it says that, it's just gonna print out. So that's what our data frame looks like. And so as you can see, I made 4 features, feature 1, feature 2, feature 3, and feature 4, and they just have some numbers. And then we have the last column is the label. So that's what we're gonna try to have the model predict. And in this case, I just made it so that the fourth feature is always the same as the label. But there might be other patterns, but essentially that might be a pattern that the model might pick up on once we train it, because that would be really helpful since that's just the label.
So now what we're going to do is we're going to separate our labels from the rest of the data, because the labels are the kind of result that our machine is going to be able to find. So we're going to copy the labels and then remove them from the rest of the data frame. So again, we're just going to hover over the little code and we're going to press the play button. Okay, and now we're going to look at the resulting data frame. So as you can see, feature 4 has a correlation to the accompanying label. So what we're doing is we're separating the labels from the feature 4. So now we're going to start training our machine learning model to find a result. So we're going to first create the model, and then we're going to run a method called fit. So in coding, a method is essentially a procedure that is part of something that's called a class and is included in any object of that class. So essentially what we're doing is when you type something, the dot fit. So it's going to be the class dot method. So we're going to run the dot fit method. And so we're telling the computer to use code from the scikit-learn library that we imported to train the model. So we're passing in our data frame, sample underscore data underscore frame, as well as the labels. Okay, once you run that, our model is trained.
And yeah, so that's basically all that we need to do to train the model. So now we want to kind of see if the model works. So we're going to try to give it like a test set, and we're going to see what it predicts from that. And so the way that we're going to do that was we're going to create a small test data frame, and that's what we want to have the model try to predict the label of. And so we want to make sure when we're doing this that the test data frame has the same number of features, and in this case, that's 4 features, as the original data frame that the model was trained on. And that's because the model learned certain patterns in these features, and it decided that certain features were more important, or it decided, again, certain patterns in those features. And if it goes to try to predict something that has different features and there's things missing, it's not going to like that. So we want to make sure that we always pass in our test set the same number of features. Oh, yeah, so I just got a chat. So essentially we're just going through the code, and if you want to try to run the code, there's a little play button here. And if you just click it, it's going to run the code for you. I'm not sure if that cleared it up. And we're just going through an example. So hopefully that cleared up the chat that I got.
If you have an error code under any of them, you're going to want to scroll up to the top, and you have to make sure that every single play button is clicked, or you're going to get some name error because you missed a step.
Yeah. Okay. So we're gonna create this test data frame that we're gonna then try to have the model predict a new value of. And so if we run this code here, we're just going to be printing out, I just called it sample row. And as you can see, this has the same features as the original model. So feature 1, feature 2, feature 3, and feature 4. And so we don't have the label though, because we want to have the model predict it, because the model learned how to predict it. So now we want to see how well the model does and what it can predict. And so as I mentioned, if we go back, scroll up to the top model quickly, as we can see, feature 4 is always the same as the label. So here it's 4 and the label is 4 and 5. And so that might be one pattern that the model learns, but we're not really sure what the model's learned. But if we look here, feature 4 is a 4. So it's likely that the model is going to try to guess something that's around a 4, just because that probably would have helped it when it was training. And so once we've created that sample row, we're then going to call the dot predict method. And so this is essentially a method, again, in that library that we imported. And this is just going to tell the model to try to apply the patterns that it learned while it was training, and try to apply these patterns to learn and predict this sample row. And so if we click the button here, essentially what this code is doing is it's telling the model to predict it, and then it's storing it to this thing called model underscore predictions. And that's basically a variable. And we'll get into a little more depth on sort of what a variable is and some of that Python syntax in our next meeting. But essentially a variable is just storing some value. And in this case, it's going to be storing the prediction of the model. So once we've done that, we can tell it to print out these model predictions. And if we run that, we can see that the model predicted 3.7. And so we don't know exactly what the model was doing. And there's some ways to kind of look at what the model was choosing in its patterns that it learned, but you don't always know exactly what the model was thinking, or maybe not thinking because it's a computer, but what the model chose to do to make its patterns. But we can tell that it did print out 3.7, which is pretty close to the 4 that it would have if it was just looking at this last feature. So that's essentially all that you need to do to train a machine learning model. And this was sort of a simple model, but you guys all, if you ran through it or if you were just watching, we all just trained a machine learning model. So it does seem really scary. And I know it seems very complicated, and some of the math that goes into it is pretty complicated, but you don't really need to know that or understand it all unless you want to be like working specifically with like coding your own model. But that's kind of a lot higher level stuff. So yeah, it can be really, really cool. It can be really fun too. So yeah.
So thank you all so much for coming today. Our next meeting will be on Saturday, May 28th at 11 a.m. During this meeting, we are going to provide an introduction to Python and Python syntax. So essentially what Python is, it is a language of computer programming. It is an object-oriented computer programming language, which basically means that it can be used for general programs, and it follows a certain hierarchy of objects. So what we're going to be going through is the very basics of Python. So we are going to learn the simples of syntax, or what combination of words and symbols are used to actually create the programs. And we are going to learn how to perform simple operations and use conditionals and loops to be able to create our own programs.
Yeah, and I know we are ending a little bit early, but if you guys have any questions, you can feel free to throw them in the chat, or if not, yeah, we can end a little early. Just want to quickly mention before we go, I know you guys might not have any coding experience, and that is totally fine, but if you do, if you go to our website, we have like a little resources place, and there's some links to some good practice coding sites. So if you want to practice, feel free to do that. We provide some resources. If not, that's totally fine. You don't need any coding background at all. We are going to introduce you to some coding, and you'll be able to do some coding yourself next meeting. So that's really exciting. And yeah, so unless anyone has any questions, I guess we'll end a little bit early so you guys can go and enjoy the rest of your weekend. And thank you so much for joining us. I really hope that you guys learned something, that you had fun. And I think that machine learning is really fun. I think that coding is really fun. So hopefully once we get into that in our next meetings, you guys will find that really fun too.